Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me, as always, is co-host Johan Oberg. Johan, what's going on today?
Afternoon, Chris. Looking out of a sunny Zurich, and feels a little bit spring in the air. But I have to say something, Chris. We're a few episodes into the new year, and we forgot something, which is on me as marketeers and communicators. We've actually been highlighted as a top energy podcast, and I don't think we've ever mentioned this on our own show. You know, we should bang the drum a little bit for ourselves.
Knock yourself out. I think you just did.
Good.
Actually, Monday I had a fun thing. I did a search for top energy podcast, and in the Google search, we actually came up at the top of the page, which was a huge moment. Now, the problem with the Google search is it changes from day to day, but that was the first time we've been at the top of the page. So it's very
Let's remember that day. That's fine.
Exactly. I have a screenshot to prove that we were there, but I'm
Excellent.
There again.
Excellent.
Well, cool. Now that we've been self-promoting, let's talk about energy.
Yep.
This episode is one that I've been wanting to do for a long time. I really want to figure out is how do we have sustainable aviation? As someone that flies a lot for a living, I'm a founder of a company. I'm on planes a lot. I'm between Houston, all the energy capitals around the world. How do I do that in a more sustainable way? And that's one I hadn't been able to crack. And so I figured, well, we should reach out and find someone that knows how to make sustainable aviation fuel.
No, I agree. And I also think, as you know, in my day job, we do quite a bit of the biogas, especially coming out of Germany, not in specifically these areas, but it's also something that's quite interesting to learn more about. And I also, being a Scandinavian, we got a lot of it from the forests. So it's also something in terms of how to use additional or extra things to produce energy from. And I think that's something I really look forward to. And then also looking at why has no one else done it? We have big energy companies out there and they're not doing it the way I look at it as well. But we'll find out.
But I think the company we're talking to is based in Denver. And I remember from my years living out there that we had this great gasohol thing that we used to put in our car. So I don't know if that was the early attempt of the ethanol on the fuel. I'm hoping my aviation fuel is a little bit more dense with energy than perhaps the ethanol that I put in my gas tank, but I guess we're going to find out shortly. So let's introduce our guest today. It's Dr. Patrick Gruber. Welcome to the program.
Hey, thanks for having me. Hey, congratulations on your Google search, man.
Cheers.
Just little things in life that make us happy, but thank you. So tell us about yourself and who you work for.
Sure. So going back, I'm one of the old timers in this space that does renewable fuels, chemicals, and plastics and things like that. I started working on this stuff back in the late 80s, 1989, and have been focused on how do you displace petrochemical-based products with things that work equally well or better and make them economical. It's hard. And I'm at Gevo now, CEO. I got a PhD in chemistry and MBA. And it takes like a pretty good group of capable people to figure this stuff out because you're crossing over industries to make something like a jet fuel. And to your point about the jet fuel, it's got to be jet fuel, man. Exactly jet fuel. No one's going to change engines and planes and all the rest. And no one's going to sacrifice mileage for a plane and things like that, or the infrastructure that goes with it. So that's a pretty interesting technical challenge.
So we are going to talk about jet fuel. I've looked at your website a bit coming into the show. We've talked a little bit in the past. So I think you just made a pretty bold statement. Nobody's going to change anything. And I think your company's belief is that you basically just change what goes into the tank. Is that pretty much the model that we're looking at?
Well, it goes into
Wing.
it is. So it's a, drop in, total drop in, goes through the pipeline, the storage tank outside. It's jet fuel. It's legally jet fuel. So once you make the stuff, get it certified, it's jet fuel, blends in, done. There's no difference commercially. So the only thing we're doing different is accounting for the carbon, and the raw material sources, of course, change, and its overall life cycle greenhouse gas footprint has changed. But in fact, it's just jet fuel. And I think that as far as, there's lots of talk on, the different sources and ways of going about.
Tell me how the process works. We talk about, putting jet fuel into the tanks, and it comes in through the pipeline and makes it work. And it's for intensive purposes, the same thing. What's the process? What are you doing?
Well, it's kind of an interesting thing to think about. So when you're trying to decarbonize these jet fuels, you got to make jet fuel. It's a hydrocarbon. It's got a bunch of carbons hooked up in a certain chain length and hydrogen. Okay. That's what you got to get to. The raw material is CO2. So you think about that. It's like CO2 that's in the atmosphere. We got to somehow get captured and then strip off all the oxygens, connect the carbons together in the right chain length, add hydrogen to it, get it formed right. So it has all the right properties. So it's the same. And there's a way to think of it is you got to do the reverse of burning, right? When you burn jet fuel, it works great because it has so much energy in a gallon or a liter, right? Huge. That's what makes it a good fuel. Well, you got to pack all that energy back in. So the question comes down to, where'd you get the carbon? Is it a good renewable source and sustainable? And B, what energy did you use to process it, to manufacture it? And so all of us who make SAF have this very same fundamental problems that we have to solve. Getting that renewable carbon, and then where'd you get the renewable energy to pack it all back in to get the right molecules?
So you mentioned in the beginning, in regards to replacing in the tanks. So I'm just curious, and I'm not an engineer, so you bear with me and let me elaborate on this. But if you are an airline and you're running on more conventional or traditional jet line fuel today, and suddenly you land somewhere else and you're going to fill up the airline, and here is the SAF solution to it, the SAF jet fuel. Is it the same thing? Do they need to clean it somehow? Is it just mix it or fill it up with the new one? How does that work?
Nope, it's all the same. So you blend it in with Petrojet, and then it's all the same fuel. You do have the certification that goes with it that somebody bought this low carbon stuff, and you'll track it by the carbon. That's how it's going to work. And it is a pretty interesting game because you can't change if you want this to go big, you can't change all infrastructure, all engines, or all airframes and stuff like that. So no, the paradigm is drop in right straight through the whole system. And once it's blended, you keep track of the carbon.
What percentage of it is actually renewable, and what percentage is still a hydrocarbon?
Well, they're all hydrocarbons because that's just what the category of the molecule is. But when it leaves our gate, as an example, it's 100% renewable carbon, 100%. When you blend it, it's certified to be blended up to 50% right now. And the airline industry is working with people like us and others to make 100% jet fuel. So over the next several years, you'll see that happen. I think there was a flight recently, that was done with the fuel made by Marathon and Virent and some other people, that just proving the point that yes, we can in fact make 100% jet fuel. So we aren't anywhere near done of what could be, but gosh, the scale is so big. It's 110 billion gallons a year or something like that, projected to get bigger. And, the world capacity for making jet fuel right now from renewables is less than 5 billion gallons or something, so we got a lot of work to do to build out an industry here.
And is this something that the military is embracing as a user of jet fuel and aviation fuel? Is this something that they're supporting this initiative? Do they want to see this? Are they funding it type of thing?
Nah, they did some early work on it and they did a good job of getting people inspired. But when it comes down to actually purchasing something, the way it works in the US is that the Defense Logistic Agency literally has to go in and kick the tires of the plant and certify that the plant operates before you can let a contract. So yes, they did early work. They did a great job and they helped tremendous. It took 6 years to get this stuff certified. It was a lot of work. and flying on all the airframes and all the engines from all the manufacturers. But it was at this point, we got to go build the plants. Then we can have that conversation. They want to buy something, and it'll be your, so you're down the road a couple of years, and we'll see who's in charge.
But wouldn't that be an interesting part, deviating a little bit from the technology now, maybe touching a little bit on the geopolitical part of it as well, because we start looking at getting rid of the dependency on certain areas. And if you look at governments or military, wouldn't it be a main driver as well, not just from the sustainability point of view, but also then to make sure that you can actually produce and maintain this jet fuel locally, because this surely could be produced anywhere.
Anywhere it can, for the most, anywhere where there's a renewable resource. And some people are working on technologies to capture CO2 directly from the air, although that takes enormous quantities of energy to do so. So yes, it does make a difference, and it does change how one thinks about the supply and dislocations of demand. And so you're right. And so in India, for example, we're working with Praj Industries, and they have waste agricultural stuff that they can convert into fuel, and they're working on that with us, and that makes some sense. And it could be the kind of feedstocks that a company like we can use. We're carbohydrate oriented as a feedstock. Some people use other things, but we're carbohydrate oriented. That means carbohydrates from crops or residual agricultural stuff, or from wood. We were the first to make cellulosic jet fuel from wood and fly it to prove a point that isn't that hard. Economically, it's hard. Technically, not so hard. It's the same. We can do molasses or sugar or picket, whatever it is that grows. We can use that as a feedstock. That's what's cool. Now, in reality, though, it's about economics too. You got to make something that people can afford to buy. And so here then is where, in the early years, we are going to have to be focused on things that are readily collected and available, and you can't stack up too many unknown technologies. Otherwise, people go, yeah, that risk doesn't feel so good. I don't like it. And, we're already doing something new by making SAF.
So you basically use agriculture products, I think, from what you just described, or that's the path you are, using some sort of sugar or some sort of hydrocarbon. Yep. So I guess, what is the sources? This is corn and other agriculture and large agriculture. How does this compete with the world need to eat, for example?
Yeah, that's an interesting question. So this is one of the fundamental ones we see over and over again, but let me just explain it like this, is that we want to use residual carbohydrates. That's the ticket, because photosynthesis captures sunlight and water, makes it into a carbohydrate. Well, we want the carbohydrates, right? And a lot of times, like with corn, you get protein too. So what we do is we take that corn kernel, separate the protein and the oil, deliver all the protein and the oil to the food chain. So all the nutritional value goes to the food chain. This is something that most people don't realize. And then we're taking the carbohydrates, which is the part that makes people fat or gives diabetes or whatever, and the people who supply soda pop are they're going, more fructose? I don't think so. So there's room there to take it. Now, you still have to do it responsibly. So one of the things that we work a lot on with agriculture is counting carbon. Where'd you get it exactly? What was it grown with? What precision did you apply your chemicals on your field? Are you building up soil carbon? We have a whole program to track soil carbon, because it builds up if it's done right with no-till or low-till farming practices, where you leave you don't cultivate it. You don't turn over all the soil and let it all go up into the atmosphere. So there's all kinds of improvements that work. Okay, that's one source. It works great in the Midwest. Other places in the world, it's going to be molasses or cane sugar, but the same rules apply. You got to prove where it came from. Was it sustainable? How was it generated? If we're doing, we have a program with a company called Sweetwater, where they're going to put a wood-based carbohydrate system on the front end of a plant of ours. That's their plan, and they got to go build it. But same thing, where'd they get their wood? We got to prove it right down to the source.
So when you talk about proving, we had some other guests on the show before talking about blockchain technology in terms of tracking renewable energy to prove it. How do you make sure that you can actually prove it then and keep that track? Because that's kind of the essence of it, isn't it?
Well, we're kind of on the zealot side of that because we're tired of all the debates that get thrown up of all the things that can't be done. I'm a big can-do kind of a person, and I like to solve problems. And so you can't do this, can't do that. Like what? Like the crop thing is a perfect example. You can't do crops; they ruin the world. Yeah, listen, it's fossil-based fuels generate 73% of greenhouse gas emissions in this world. It's not, that is where the problem lies, so come on, people, let's face it. It's about electricity. It's about heating things. It's about manufacturing plants. And yes, also about transportation. All right. So great. And we're going to work on all those things. So we come along and we're real focused on, let's just document the sustainability, data driven, and prove it. So we are huge believers in tracking stuff. Where did you get your carbon? So here's something that happens. We have a bunch of people out in this industry who think that taking a fossil-based piece of plastic, liquefying it, and then making it into jet fuel reduces fossil-based greenhouse gas emissions. It's like, what planet do you live on, man? That's like this. How does that work? And yet you have people, in the interest of, I want to do something sustainable. If we take waste, that'll be the answer. It's fossil-based waste, for God's sakes. What are you talking about? You burn that, it's still a fossil-based emission. Can you stop talking like that? Instead, let's get serious about, no, we need renewable carbon. Where does it come from? Really? And you got to document it. And this is the reality. We're in a world where we're going to have to document everything because no one believes anybody anymore. Hence, we have a program ourselves that we call Verity Tracking, which is a blockchain technique. We've already proven it to work. We go to the farmer's field, look exactly what they do, what farming techniques, what chemicals do they apply, what's their soil carbon. We have it certified by auditors, attach the information to blockchain. That information gets attached to the corn in this case. And then in the processing, we're separating the protein and the oil, tracked. We're applying energy, tracked, all documented, attached to the lot of fuel, off it goes to the market. And that's how we think it should be done. And we're committed to it. So Verity Tracking, we're going to set that up as a standalone business. And we already hired the CEO. And we believe that is just what has to be done. And you know what? We had people come to us and say, hey, could you help us with in a refining industry, track from the oil wells and help us document so we can reduce the CO2? Heck yeah, we would do that because this is all part of the game of trying to solve the big problem of greenhouse gases. We have to measure things and reduce them and quit game playing.
All right. So I totally understand the tracking. I see the value of that going through. So let's go through the carbon life cycle here, because basically you're creating carbon and then there's some sort of sink. In this case, I assume it's the corn or some other, if it's sugar cane or wood or whatever you happen to be using. But each of those would have a different rate of collection that would be different, I would assume, right? Corn's a fairly short life expectancy, and growing a tree might take a while. So who's more effective as a carbon sink? And do you need to augment that with additional carbon sinks to make this actually net neutral?
You have three possibilities for carbon sinks, roughly. One is in soil carbon. There's capturing, like a forest has a bunch of carbon capture, but if you're going to harvest stuff, you got to do it at a balanced rate and figure out what that is. That's part of the reasons you got to really do it in a measured way. Corn's the same way, is that you can't, if you do you dig up all the roots every year, like in a conventional tillage. Well, that's stupid. You're turning and wasting chemicals and nutrients in the soil. So what's happened here in the States is that about now 50% or more are do low till, no till. So they don't do the tillage. They actually do a little tiny strip, leave the root systems intact from year to year, plow a little strip, drop the seeds in, or they just leave everything there, cut it down and put a drill and punch through and drop the seeds in. That saves money on fertilizers and chemicals and nutrients, and it keeps moisture on the soil and all the rest. But it also helps build up carbon. So that's soil sequestration. That matters. But what matters to make it happen, you got to have agriculture done right versus old-fashioned techniques where you just don't care. You got to measure it and do it right. There's a second way of doing it. In a process like ours, we have a fermentation. In the fermentation, we're taking the carbohydrate, do a fermentation. The fermentation makes CO2. It's renewable CO2. So you can capture that and sequester it. That has a possibility as well. Put it down a hole geologically. Or you could make something out of it too. We have a program to look at that as well. Make plastics, for example, because that also could be sequestration. And then you have a third area, which can be done for sequestration, and that is in the energy itself. Because it takes heat to run a plant, electricity to run a plant. So there's we're working with ADM, and they have a great sequestration site, and we want to generate power, and they've been operating the sequestration site for 10 years. We know we can sequester the off gas from energy right down the hole. Again, each time it's a specific thing. It's got to be well documented, well measured, and all the rest. Otherwise, no one believes you. But there's a couple lessons here. There's no one universal solution. There isn't. Each thing is going to be a little bit different depending upon what, where, how, and hence this is why the tracking becomes so important.
So when this is all in place, do I still get shamed for flying from people?
Well, you're going to have people who just say, stop using this. And I'll tell you what, I grew up in the Midwest in St. Paul, Minneapolis area. And I didn't know anybody who was rich. Okay. I didn't meet people who flew until I had my PhD and a professional career. It wasn't done. And now granted, I'm old and the people didn't fly so much back then, but it's a privilege to fly. And there's a couple points of view in the world. I'm not a big fan of an elitist attitude that says, don't fly. You shouldn't fly. I'll fly. You don't fly. I'm not a big fan of that. That just sticks in my craw. And so, you know what we should do? Why can't we work together to solve the problems and fix them? Because they're totally doable. It's totally doable. The technology exists. So why don't we work together to solve it and make it available? Because do you know what? People have better options and a quality of life if they can travel. So these are just cultural things that we're going to be here. Long way of saying is that you're still going to get shamed by some fringe group.
You're still going to get shamed, but net zero is the flight, is your goal here.
Yeah, totally. That's what here's something really interesting. Think about that. We're measuring the CO2 from into the crop, all the way through the whole system, manufacturing the fuel, and then to the tailpipe of the engine, net zero. Okay. So after it burns, it's measured as net zero. Sitting in a tank at our plant, it's minus 90 plus. It's sequestered carbon sitting in a tank as energy. That's a mind-blowing thought to me. I mean, what the heck? Are you kidding me? It's like minus 90 plus, more than that even. And we can make it even more negative by how we do the sequestration routes and balance our plant out. That's a mind-boggling concept, right? In terms of what's possible to do. And that's part of this is we have to teach people about it. And it's not general though, right? It depends. I got my system where we're documenting the heck out of it. Other people don't have something like that. They don't want to document it because don't bother me with where that came from exactly. I think everybody should document where did they get that carbon.
But I agree with you. And I think this whole documentation will come faster than we think for organization and then down to us as individual. This will be, I think this is, I wouldn't say a no-brainer, but we will start measuring it more and more and more. But coming back a little bit to this kind of ecosystem that you mentioned, that you spoke a little bit about in terms of how do we do this? Because one alone might not be able to do it. Now, I did some in my pre-research around this. I saw, I think, a press conference with you or an analyst review. You talked about something called the Circular Earth Friends business model in regards to this. When it kind of caught my eye a little bit in terms of how the different parts in this ecosystem all plays together somehow.
Yeah.
Can you elaborate on that?
Yeah. So we're big on that kind of a concept. It's a fundamental sustainability concept where recycling nutrients is what we're talking about. So CO2 starts in the atmosphere, gets captured by photosynthesis, makes it into a carbohydrate. We process it to make a fuel. The fuel burns and makes CO2, right? The only input to that then is the energy that would take to make the fuel. So we need green energy, which, by the way, this is like one of these bald truths that no one wants to acknowledge. Our footprint comes from fossil-based electricity, which in the U.S. is greater than 60%. And everybody forgets that. We're gonna have electric whatevers. I got news, man. We got a problem here. The electricity is fossil-based. In Europe, in various countries, it's better. Here, not so much. And then it's from natural gas. That's what creates our footprint. You know what we're doing? We're simply making zero footprint electricity, zero footprint gas. That's what we're doing to get to our net zero hydrocarbon fuels. That's mind-blowing, I think, as well, because it's that simple of a problem. Everybody could do it, frankly, who, if they got their act together and said, I want that green electricity. My EV guys are my friends. You know, I got to help build build EV stuff. I'm going to build hydrogen. Same thing. So that's all part of it is what's that circular relationships look like? I'm going to have those partners. And in our system, we're also making protein, as I mentioned. So we capture the protein. It goes to animals, feed dairy cows. We have a business we just started up where we take the manure and digest it to make the biogas. Why do I want biogas? Because I can put it to my plant. Although right now we can make more money selling it to California for vehicle. So we'll do that first. But, we can always take it to our plant because the main enemy in my business system for fossil-based emissions, and by the way, my fossil-based partners hate when I talk like this, but it comes down to the fossil-based energy we're burning, man. That's what the emissions originate from. That's the majority of the world problem right there.
So I get the life cycle. One thing that came to my mind as I was doing the show prep and thinking about this is I totally understand each of the segments, but as weather gets more extreme and I get reliant on crops to produce my energy, is there risk, right? I mean, my dinosaur bones are probably pretty safe under a hurricane. They're probably still there, or my shale or whatever I'm getting my fuel from, or my natural gas supply. Cornfields or other plant-based material are probably more susceptible to these once in 100-year events that seem to take place every other week these days. What's your thought there?
Yeah, so I'm going to broaden it. It's a diversity of feedstock question. What can be done and what happens over time? So we'll start off on corn because it's there. We can document the sustainability and all the rest. But I already mentioned we can use wood. We can also use agricultural residues. There's a sequence that those things have to come into play, though, because as I mentioned, the technologies to do cellulosics or residuals or agricultural waste and stuff like that, or municipal solid waste, those technologies are more complicated. They're going to take more time. But having a person like me downstream of them going, I can price it. You show me what the sustainability is, the quality is, and I can tell you what the price is. And then now we can make a business system that works. So we're going to see this evolve over time. Okay, so that's one thing. Multiple feedstocks are fair game for us. And as we said, all around the world, it will be different. It will. That's just the nature of what it is. Now, as to what happens in overall change, I can tell you that when I was a kid in northern South Dakota, corn didn't grow there. It does now. It's going north. So it isn't this all or nothing. I'm not a big proponent of these extremist points of view. It isn't. It's never, black and white anything. It's a question of how does it migrate in this case? Is the Corn Belt moving north? That's an interesting question. Sure looks like it to me in certain parts of the country. And so it's not just as simple as any one thing, barring, an asteroid hit.
Yeah, well, that's a little bit harder to predict. But is there a price at which a barrel of oil makes this all work or not work, or is this totally driven by politics of wanting to be carbon neutral?
Today, it's driven by politics of wanting to be carbon neutral. I think that, it works if we're at $80 oil like we are today, I didn't look today, but it's somewhere around there, I suppose. We're probably, that helps a lot at 100 and 100 plus. It makes fundamental sense. But none of this matters unless you care about carbon in the first place. Unless the world cares about it. And this has been the problem is like, the consumer at large goes, sure, I want that. Oh, but I don't want to pay more. Not really. And then there's a small section of people that will. You have airlines themselves. I want that product. Reduces the footprint, makes me look good, gets shareholders off my back. But do I have to pay more for it? And it's a fair discussion. My gosh, fuel is their biggest cost component. So I actually am sympathetic to that. So that's part of what we have to do to work it out with them on how to sell something to them, because they should not be unduly penalized, right? But will customers really step up and pay for it? How does that happen? We're talking about the petrochemical industry they grew up at a time when they had state-sponsored money to help them build stuff. We don't have that so much. So now we're using carbon value to help us get that.
So on the flip,
go ahead.
So on the flip side, we looked at the oil versus the oil, but is there a risk, hypothetically, I guess, but market price and market values where suddenly now there's no corn in the US because we're buying all of it for jet fuel?
Well, I don't know. You got like I think the amount of corn in the U.S. is going to be like 14 billion bushels, and
So
14
you're pretty safe.
pretty much. And
All
seven,
right.
yeah. You talk, and not that we have technology that can convert ethanol into jet fuel, and making jet fuel out of ethanol is more valuable than making ethanol itself, the gasohol. And so we think there's a lot of opportunity right there without even changing infrastructure at all. But then the rest of the world is only at about 80% of the corn production that the U.S. is. They're just learning how to do it in modern agriculture. And there's one of the things that we have to fight is people have these misconceptions about the agricultural side of things. Oh, it's bad. It pollutes the earth. It's a worse danger than, anything else. That's not true. It's just factually not true. It's just not true. And you can generate protein. If you care about nutrition, you care about protein, you can generate the protein anyway and sell that to the food chain. So it's not one or the other, these binary things. And as I said, we grow up, I got to have renewable electricity. And you know what? I can help the EV guy get renewable electricity in places he'd never try to go to otherwise, right? Because we're going to be in a different location than what they are. So it's not, we got a big global problem here. And it's going to take everybody working together and getting rid of the parochial ideas and start to think about how can we make the whole systems better. Hence such an emphasis on the system and tracking and figuring out where the problems lie.
You mentioned earlier that you use renewable energy to make this process take place. You need energy to do this, to make this. And I think on your website, I saw that you use wind energy. Is that one of the alternatives? Is that what you do?
That's one of we actually have wind towers at our plant in Laverne, Minnesota. We're planning on putting up a 60 megawatt wind farm near our Lake Preston site. And that's what would give us the power. We'd have it behind the meter going directly to our plant. And, the mayor of Lake Preston, he asked me if we'd be helping put up EV charging stations. I said, sure. We'll do that because it's about the right distance from Sioux Falls so people can drive their Teslas up and now they can have a tourist business. The idea to build hotels because it's true. You got to have the infrastructure. Well, we can help catalyze stuff like that. Same thing true with hydrogen. We're going to make a bunch of hydrogen from the wind and we'll make some for ourselves, but we'll make extra for people. So it's a renewable energy, renewable natural gas, biogas, all those things matter because our footprint in making any of these products always comes primarily from the electricity source and the heat source. Always.
So how do you scale this? So you're already a public company. So how do you get this to be that every plane I get on is got some sort of renewable fuel? I mean, how big a plant and how many do you need around the world to make this a reality?
We have a goal of about 1 billion gallons by 2030, and we can see how to do that by building some greenfield plants and then also co-opting existing ethanol plants and decarbonizing them. So this is the program we do with ADM, right? Is they've got pretty big plants of ethanol, and you take one of their ethanol plants, and it's like 900 million gallons of ethanol in would make 450 to 500 million gallons of hydrocarbons out, and we got to decarbonize it. So that's the mission at hand. But we can do it we're designing a system that can be translated with, any other ethanol plant that's around the world. So that's the system we're designing, but we have to decarbonize at the same time. So we developed a whole set of partners who help decarbonize. And it always comes down to fossil-based electricity. We got to get rid of it. Fossil-based natural gas. We got to get rid of it. That's the mission. And it's crazy that a company like me who's doing jet fuel, where this is like a lot of our energy our own internal energy goes to solving that bigger green energy problem. That's the fundamental problem for greenhouse gases. That's where it originates.
But it's an interesting part around this. In my previous career, long time ago, I'm old as well, we worked a lot on these kind of services, on conferencing and collaboration services. And obviously one of our targets was traveling. This is end of 90s, early 2000. We didn't call it sustainability then. We called it CO2, whatever it was. More of a window dressing in my point for the corporates. But you saw that the travel was a big thing in terms of corporate wants to reduce their travel. Sustainability was probably the kind of the PR thing, whereas cost was the main thing. But if it's been going on for such a long time, why haven't we seen more investments more drive towards this, and maybe especially from, well, with all due respect to all of us, but the big boys, that there are the main producers of the traditional fuel.
Yeah, I think it comes down to a lot. I'm cynical. I'm old. I've been doing this stuff since 1989. So this is the caveat to try to get me out of trouble. I listen to all the talk about sustainability, and most of it is BS. I mean, I am shocked at what I hear when people just throw this stuff around, and it's like, you kidding me? Let's prove it. Let's show the data. I'm a big data guy. So historically, then, it is about just getting people off their back, playing lip service. What's changed is that carbon is now valued. So this only happened in the last few years where it was reliably valued. It used to be that an investor would say, sure, I'll invest if you can do the same price as petroleum. It's like, wait a second. Those guys are a 100-year-old industry, fully depreciated, operating at marginal cost. I got to build new capacity with new stuff, and you want it to be finished product price competitive. Really? Yep, that's what we want. So what's changed is LCFS in California has done an outstanding job of pricing carbon and holding it steady and managing it in a reliable system that's database, science-based. I don't agree with all the things they do, but they've done a real good job. And that's part of it, and it got renewed a few years ago. So that signaled, it ain't going away. It's real. Along with that, you have the EU RED policy, EU RED 2 policies, the discussion of which it makes people go, oh my gosh, this is going to hit us, right? So you have the firming up of carbon price. You have the RFS policy, which does work in the U.S., and you have other things going around the world. It's these firming up of carbon value. So now investors say, I think that carbon value is going to increase in time. We understand it. And so now we can put an investment in against it. It allows us to strike a deal with airlines that says, hey, we'll share some of the green value with you. And that gives you a cost structure. You're sharing green value, but it gets you down to the net price of what it would be if it was petrol-based. But at least you're taking some of the risk on the green value side. Those things would have been impossible a few years ago. But the whole combination of concern around the environment, the firming up of carbon, activist shareholders, all those things come into play here that's causing this change to occur. On a fundamental basis, a product like ours, on a just the marginal cash cost basis, it's not too different than petroleum. However, we have to build new plants.
So what's the risk? So it all sounds really rosy. The world sounds like it's headed to an amazing place. You're running a company. You guys are off to the races. You're scaling up. What's the risk? Why could this not happen? What would keep this from happening?
Uncertain carbon policies, the devaluation of carbon. There's somehow a change where people say, yeah, I don't care anymore. That could be a hassle. It could be that oil drops to $20 a barrel again. That could be a hassle. So but in this case for me, it doesn't change none of those impact us in the near term. You're talking then about the destination, how big is the market ultimately kind of questions, right? Because you're still going to have it where people will pay for it because they got to do it kind of thing. So 1 billion gallons, good. But we're talking in a SAF world, it's 100 billion gallons plus. So we got a lot of work to do. And they publicly talk about wanting 30%, by 2030, 2040, and, more than that. That's like 30 billion gallons. We got a lot of work to do for that. And so it's ultimately the stuff is going to get priced into the flight ultimately. But how do you do that over time? You don't just, there's lots of chicken and eggs here that we have to solve, right? We got to go build capacity. It takes 2 years to build a plant, 2 years. And so we can do one here, one there, and then we could do 10 at once we know how to do it well, or 20. We could do that. But that's still, you're talking about, it's going to take a decade to build out capacity.
So I reckon, obviously, there's a big gap, there's a big opportunity, and it seems like endless, to replace. So I think that for SAF, I think that's not really the challenge. Challenge is to actually to get the demand. But if we look a little bit apart from the SAF part, are there other areas? We talked about electric vehicles. I think that's kind of, the vehicle ones might be done in terms of if you look at the OEMs, but we look at ship cargoes, heavy duty traffic. Is there anything else that you think that you might not be able to do due to the capacity, but that they could be used from?
Yeah, here's something really interesting. We're not that brilliant here at Gevo. We're copiers. So what we did is we looked at the petrochemical industry and looked at how they do things. They use these building blocks called olefins, the ethylene, propylene, butylene, and there's some others. They're these fundamental building blocks they get from cracking. Everyone's heard of cracking of oil, but that's what you get at these things called olefins. You know what we're doing? We're making renewable olefins. You know why? Because when we make the renewable olefins, they just drop in and you can make everything. That's actually what we're doing here. It's a very fundamental infrastructure type of thinking so we can leverage, because these poor guys on the chemical side, you know what? We should be able to substitute their raw materials and keep their plants running too. They need jobs. And out of that, then we don't have to invest in that capital. So that's also part of this game. Yes, the thing we're focused on initially here is SAF, but everything's fair game because we can make these olefins. And the technologies exist to do it already. However, when you're thinking about plastics and materials, there's no carbon value to that. Nobody cares. Not really. It's just a little tiny niche branch thing. And I can say that because I was the guy who did PLA plastics, and led that business when I was at Cargill. And I'm a seriously scarred person because of it, about the way the world actually works versus what I thought it did. It's like, no, it's a game of, I don't want these niche. We got to change the world. I want to change the world kind of a thing of what's possible. And we have these technologies. We got to deploy them. And so this is about making something that works great at a competitive price. That's what it comes down to, and make it easy to adopt and convincing people. So that's the game we're in. And you see that we're getting lots of traction with all the partners that we have across industries. So we're these strange people who can work on petroleum side, agricultural side, integrate. And because we're not particularly biased, we're data driven. We'll solve the problem.
What continents are your aviation fuel available today? Is it still just the U.S. because you're growing, or would I have hopped on a plane, or could I be getting on a plane here in Europe that has your technology?
Right now, I think we're doing small amount. We only have a small amount of capacity. So if you're flying a business jet, and depending on what city you're in, you might get some of our stuff. And we have sold stuff into Europe before. And so I just don't know that there's nothing that comes to mind right now. We will be doing European stuff. This technology works in Europe as well. And it comes down, I'd like to see the policy get stabilized. Like, what is really on what list, really? I'd like to know that. And, what works and what doesn't. I see that, I think that people are like, there's an automatic response to agriculture is bad. It pollutes the earth. That's wrong. That's not true. Some does, some doesn't. And we should sort out which is which. And for the ones that don't do it well, we should teach them how to do it well and actually give them the equipment. I'll tell you a short one about Jordan, the farmer, okay, who is at our plant. He grew corn. We have acreage around our plant in Minnesota. And Jordan, young guy, he's growing some nice corn. I'm like walking around with him, looking at his corn that he grew. He's like, cool. We rented the land to him. So Jordan, you use conventional tillage here. Why didn't you use low till, no till? And he says, I'd like to, but I got the farm from my dad and equipment from my dad, and I don't have the money to buy that equipment. I'd like to do that. That's what should be done. And so here's a guy making a living. He has to do conventional tillage because he doesn't have the money to buy the fancy equipment. Here's another case of privilege, man. So how do we help this? How do I help Jordan? So that's the kind of stuff we work on, is I want to see programs that help Jordan and people like him, and to get to these advanced tillage practices, because you get more yield per acre. It reduces the chemical inputs, it's better for the environment. So that's just part of the problem. It's just this black and white attitude, all bad, no good. Let's do something different. No, really, let's sort it out and figure out how to make things better.
Cool. So I know we're coming up for time. I can go on forever. I got so many questions. I have a whole notebook down here. But one of the things I always kind of want to ask on this show, especially when we bring on, I wouldn't say newcomers or scale-ups, but at least disruptors, is you're coming into an industry that you're replacing, or you're disrupting the industry. How are you welcomed? How are you working with the legacy, the traditional industry? Are you working together with them? Or are you hands-on clashing? How are you perceived in terms of actually making this transition happen?
Well, I think that over the years that I've been doing this, it started off as, that'll never happen. They're full of crap. Because, you can't go from agriculture into classical hydrocarbons. Okay, now they all tried and failed, and they recognize that guys like us are still doing it, and we know something. they now perceive us as people who know how to cross the bridge from, where do you get the raw materials? How do you process them? How do you take that complicated biological system and turn it into a hydrocarbon system that they know and love? And they've caught on to the fact that we're co-opting their business systems so they can make money too. And this is fundamental about how you take something to market. It isn't, hi, let's shut down oil. No, let's co-opt them. Use their distribution. You heard me talk about the olefins, the building blocks. You know what? We can co-opt their plants in the future, So it's not a binary, we're going to shut those guys down. Now, if we're successful, what'll happen is they need less oil pumped. That's what'll happen if we're successful over time. So they can still make their plastics. They can still make all the other stuff. And we can make jet fuel and gasoline and diesel fuel and bunker fuel. All those, fair game.
It sounds like you're spending a lot of time having to educate people and get the market. You talk about naysayers and people that just kind of say poo-poo on the idea without understanding it. So is that probably one of the risks too, that to get the market just acclimated to the concept that these fuels are still going to exist in your model here, and that they're going to help sustain the lifestyles people have become used to, but yet they won't impact the planet? Is that the biggest challenge that you're facing right now?
No, it's not the biggest challenge. No, the biggest challenge is getting everybody on board and getting things financed and getting, the whole business system built. That's the physical challenge. But this thing you're talking about, it shows up in the form of people like simple stories. I'm going to use waste. Waste is good. No, it's not. It depends on where you got the waste and what it's made from. So, that's where the education parts come in. Oh, corn. That's my God. Corn. Most people don't know that less than 1% of corn is actually used by people. And you know what? It isn't the kind that's grown in the Midwest. That's a different kind of corn. The kind that's in a can or a bag or on a cob ain't the kind that's grown. That ain't two different things. People don't know that. It's, there's a tremendous amount of education that has to be done. So you start out, you have to be a real principle-based system. And the people who are deep into sustainability stuff and really thinking about the bigger systems, they recognize there's trade-offs all the way along. This is the point of the documentation of it, though. You got to really be all over it and paying attention to it, because you can create a bad consequence. So, let's see, there's this great pile of wood down in Houston. Love that pile of wood in Houston. It's huge. I bet you it's got 15 years of supply of wood waste that we could use as a feedstock. And it's from hurricanes and tree branches blowing down, stuff like that. Okay, cool. My plants are going to run for 50 years or longer, right? And so at 15 years, are we going to count on more hurricanes replenishing that pile? Or is someone going to all of a sudden go, I need to cut down more trees or find more wood from somewhere? So how do you deal with that? And that's like stuff that we're all learning about. How are we going to sort that kind of thing out, really? So there's not easy answers anywhere on any front. So what do? You break it down into problems you can work on, sort it out with data, and deploy. But it is about also being super transparent. Like I'm talking about, we're going to do radical transparency. I hate saying radical transparency, but you know what I mean? I mean, literally, we're going to show people from the blockchain, you'll be able to go press the button. That's how much wind, that's how much biogas. That's where these are the farm group it came from with their footprint. That's what we're going to do. And we think this is the only way to end the debate about where did stuff come from. And we would do this if it was that pile of wood. We'd also be documenting it as to what the inflow outflow of that pile of wood is down in Houston. Same thing. You'd be paying attention to it. You can't just do the big hand waves. That's not how this is going to work in the future.
Well, I appreciate the explanation. I can sense just a tidbit of passion when you speak, that you're passionate. So I get the education. I get there's some economics that need to make sense, so that the folks are lining up to give you the pension funds, and all those folks are saying, hey, let's help you build these plants that are a couple of years out and look at these models and things like that. Hopefully that's going to line out for you. I've enjoyed the conversation. I don't really have much more to go on. I think it's met my need to figure out what a zero carbon jet fuel could look like and what the world may look like as we go forward. And I always love a passionate founder or passionate CEO to tell me about what their company's doing. Johan, any final thoughts?
No, I really enjoyed it. Pat, really great to have you on. I thought it was fascinating. These are areas I knew very little about. We've worked a little bit on biogas before. And I thought it was really good. I also thought it was quite interesting that we spoke so much about corn. I never thought that when we set up the Insider Guide to Energy that we're going to have a episode talking so much about corn, but I really appreciated it.
Yeah, it's one of these strange things because you start really thinking about, where am I going to get that carbon source? Where? How? You start going, what are collected now? What will be collected in the future? How do I get it and skin the cat? Because we need renewable carbon to make this all happen. So that's why the corn. And I appreciate you guys having me and allowing me to just ramble on.
Well,
our pleasure.
It's been a pleasure hearing you speak today. And thank you so much. For our audience, you've spent another hour listening to Insider's Guide to Energy. We hope you've enjoyed this conversation as much as we did. If you did, please share it with your friends. Please don't forget to subscribe and maybe even catch this on the YouTube channel. We'll talk to you again next week. Bye-bye.